Hi guys, greetings to you all. Welcome to my YouTube channel. Today I would like us to look at curve sketching, and I'm going to give a procedure to sketch, a general procedure to sketch functions, the curve of functions. And to do that I will use an example. Let's say we are given the function f of x equal to 2x plus 6 over x minus 2. So generally when you want to start sketching, the first thing you look at is the domain of definition of that function. The domain of the function refers to where the function is defined. Where the function is defined. So we are going to look at where this function is defined. Now, looking at this function, you see that the denominator, since it's a rational function, if x is equal to 2, the denominator will be 0. While the numerator will be 2 times 2 here, 4 plus 6, 10 over 0, which is undefined. So for it to be defined, the domain x should not be equal to 2, which we can write as real numbers excluding 2, or we can write it in interval form. We can write the interval form as x belonging to negative infinity 2 union 2 positive infinity open. So that's our domain in interval form. Now, having done that, we evaluate the limit at the bounds of the domain of definition. That's the limit at negative infinity. This 2 is 2, this 2 from below, this 2 above. Okay, the limit at negative infinity of our function x tends to negative infinity of f of x. We saw in the previous video tricks to obtain limits. It will simply be the limit of 2x over x. That's because the highest term here is 2x, here x. So we have limit 2x over x as x tends towards negative infinity. 2x over x is 1, and the limit of a constant is a constant. So the limit as x tends towards negative infinity is 1. Likewise, positive infinity will still be 1. Okay. Now the limit from below, the limit as x tends towards 2 below of this our function of f of x. How do we obtain it? From below, this is what below means, 1.99. Normally below, if you are to substitute 2 in this our function, if you are to substitute our 2 here, it will be 10. That's 2 times 2, 4 plus 6, 10, which is a positive number, right? Which is positive. Now if you are to substitute 2 here, take note that since x not equal to 2 here is the domain, means x equal to 2 is what we call the vertical asymptote, which will come there. 2 below, if you put here with 0, but slightly below, you see that any number less than 2, if you take away 2, minus 2, it will be negative. So the 0 in this case will be negative. Positive over negative give us negative, so we have negative infinity. Likewise, if you take the limit as x tends towards 2 above of f of x, it will give us, above will still be positive. That's when you substitute 2 up, it will still be a positive number. Okay. Now slightly greater than this 2, it will be, let's say, 2.001, and 2.001 minus 2 will still give you a positive number. So the 0 will be positive. Why are we saying 0? Because if you put 2 here, normally we are looking at the same. If you put 2 minus 2, it will give us 0. And a number divided by 0 is infinity. So positive divided by 0 here will give us positive infinity. So we have obtained the limits at the boundaries of the domain of definition. Now, since this limit at 2, it gives us infinity to infinity, is telling us that the line x is equal to 2, as the line x is equal to 2, is the vertical asymptote. And the line, and the limit at infinity gives us, the limit at infinity gives us, sorry, it gives us 2 here. Let's correct this, 2. 2x over 2 is 2, sorry. So it gives us 2. So the line y is equal to 2 is the horizontal asymptote. So here, so for us, when we have calculated the limit at the bound, it gives us that the limit at infinity, it gives us the horizontal asymptote. It will tell us how the curve will behave about the horizontal asymptote. So we have here 2. Okay. Now, if you take the limit at the domain, or for us to have the vertical asymptote, what we can do is we set the denominator to 0. If you set x minus 2 equal to 0, you see that x will be equal to 2. It means 2 is the vertical asymptote. X is equal to 2, sorry. X is equal to 2 is the vertical asymptote. So having obtained these values, having calculated these limits, is a great step towards sketching our function. Now, having done that, we'll look at okay. The next aspect that we'll look at now, have a look at those limits, obtain the asymptotes. And before I go to intercepts, an asymptote is simply a straight line that your curve will never touch. A straight line that your curve will never touch, never cross. You will only approach it. That's what we call an asymptote. Now we're going to go straight to obtain the intercepts. Since we are doing the sketching, the intercepts. The intercept there from our function means the y-intercept s equal to 0. When you substitute 0, we have 6 over negative 2, which is negative 3. That's our y-intercept. Now the x-intercept is when y is equal to 0. And if y is equal to 0 from our function, remember our function is 2x plus 6 over x minus 2. And since the denominator is different from 2, it means if y is equal to 0, the numerator is our focus. 2x plus 6 equal to 0 implies x is equal to negative 3. So here we have 0, negative 3, and the x coordinate first, negative 3, 0. Okay, having looked at the intercepts, we go straight away to obtain the derivative of the function, so that we are able to determine whether there are turning points or not. And since it's a rational function, when we obtain the derivative, we will use quotient rule. And when that is differentiated, we are going to have negative 11 over x minus 2, all that squared. Now, knowing that the denominator here is a square and the numerator is negative, it means the derivative is a negative, gives us a decreasing function because it's less than 0. Negative divided by positive is negative. And having a numerator like this one, a numerator being a number, it tells you that you cannot solve for any x there. So there is no turning point. That's the next thing, there is no turning point. This curve has no turning point. Now, having obtained these important points, we are ready to have a sketch of our curve. And we can represent this all on a table that we call the table of variation to ease our work. This is our x here. Then here, this first row is our domain. So the domain, we had negative infinity, we had 2, all those bounds, we have positive infinity. If there was a turning point, we will include it in any of these places following the number. Now we have the derivative here, f prime of x in this column. We have our function itself, f of x here. Now this 2, x equal to 2 is a vertical asymptote, indicate. And the derivative of that function, you say, is always negative. So here is negative, here negative. Now when we calculated the limit as x tends towards negative infinity, it gave us 2. It gave us 2. Since it decreases, you put the 2 up, it goes down. It decreases to the limit 2 below. This 2 here before, it means 2 from below, which when we evaluated was negative infinity. So we have negative infinity here. And we come this way, 2 above. When we evaluated the limit 2 above, it gave us positive infinity. Positive infinity. Then this, when negative here means you are going down. Okay. And positive infinity here gave us 2. So we had here our 2. Two is here. Yes, 2 is this way. The 2 is here. So that's it. Having obtained our table of variation, we go straight. This table of variation is already showing us how the curve will behave. When f of x is equal to 2, it start when f of x is equal to 2. That's y is equal to 2. It slopes down. Going, when you see negative infinity here, it means it goes to the negative, that line just before this 2. It goes below to the negative y-axis. Now after 2, this is how we interpret it. After 2 here, we have positive infinity. Okay, it means it starts from this one will be up. Positive infinity, f of x positive infinity means up on the positive y-axis. So it will leave the positive y-axis, approach 2. That's how the shape of the curve will look like. Okay, let's see how the curve is. Okay, so having obtained from that table of variation, this is our curve. You see, we represent the line. This is the line. This line like this is our line. The line x is equal to 2, which is our vertical asymptote. And this is the line y is equal to 2, which is our horizontal asymptote. And remember, as we had from our table of variation, we had that from 2, that's below 2. This is what I mean by below 2. Okay, y is 2, so it means it approaches this intercept, comes down, passes through, it approaches this asymptote, passes through the intercept a here. This a and c are the intercepts, passes through, then goes to this other vertical asymptote. Now still on our variation table, we had after 2, I said f of x was positive. It left from positive to 2. Positive infinity means above. If f of x is positive infinity, means on the positive y-axis. That's why we have our shape here above. Okay, thank you. Please feel free to subscribe, like, share, comment. In the next video, we'll look at other functions. Thank you.